Recorded. So into 4. So 12,000 joule per Kelvin. Yes. So if you write in the decimals, this is 1.2 into 10 to the power of 4 joule per Kelvin. Look at here. So the given power, mass and change in temperature. So we can find out the heat energy, right? Delta Q, mc delta T. In this, C is a specific heat capacity. So first we can find out using the power and time. So heat energy. Heat energy is power into time. From this specific heat capacity we can find out. But we need heat capacity at a mass 4 kg. So heat capacity, specific capacity into mass. Oh, 1 minute, Tejas. సరే సరే మా సరే తగిలింది బాగా సరే కొట్టేసాం అమ్మా అమ్మా పో అమ్మమ్మ పో వెళ్ళు కాలు కింద పెట్టేసింది. So next is 8th one, 0.5 kg of lemon squeeze at 30°C is placed in a refrigerator which can remove heat at an average rate of 30 joule per second. How long will it take to cool the lemon squeeze to 5°C? Specify heat capacity of squeeze. 4,200 joule per kg per Kelvin. So what they have given here, m
0.5.
yes, 0.5 mass and rate of change of temperature also 30 and 5. So if you do the difference, 25.
Yeah.
Next.
And the specific heat capacity.
C also they given, right? You can find out what first heat energy. Then afterwards, using of the heat energy, time you can find out. Time is what? T equals to delta Q by P.
T.
So 8th one, given mass equals to 0.5 kg, m equals to. Next, change in temperature. Delta T equals to 30 minus 5 equals to 15. Oh, 25. So 25 Kelvin. Next, specific heat capacity, specific heat capacity C equals to 4200 joule per kg per Kelvin. So delta Q equals to mc delta T.
M into MC delta T.
So 0.5 into 4200 into 25. How much? Multiply delta Q, you'll get it. Then write T equals delta Q by P. So what you are getting, write it, and P they have given 30 joules per second. Multiplication, how much you got it? Here one decimal remove from 1 0. Then 5 into 420 into 25. 25 5s are 125. 420 into 125.
Yeah. 5 to
Yes, 5 to
52,000, 52,500.
52,500. So 52,500. 0 0 cancelled. 3 ones are 3, 2 22, 7s are 5s are 0. 1750 seconds it is. Then convert into the minutes divided by
Yes.
60. So 0 0 cancel. 6 2s are 12. 5 55. 55 means 9s are how much rest of 10. So 29 minutes 10 seconds.
Yes.
Next,
That's
yeah, ninth one you see. A mass of 50 gram of a certain metal at 150 degrees Celsius is immersed in 100 gram of water at 11 degrees Celsius. The final temperature is 20 degrees Celsius. Calculate the specific heat capacity of the metal. Assume that the specific heat capacity of water is. So a mass of 50 grams of a certain metal at 150 degrees Celsius is immersed in 100 grams of water at 11 degrees Celsius. The final temperature is 20 degrees Celsius. Calculate the specific heat capacity of the metal. Assume that the specific capacity of water is. What you understood? Tell me.
they gave us mass and then there's that okay.
Here two is their
All
substances. What are
yeah,
that? Metal and water.
metal and water. Okay.
Understanding? So heat is liberated by the water and heat is absorbed by the water, liberated by metal, absorbed by water. Two cases are there here.
Yes.
But heat never, we can't get it. That means we can't, there a conservation of law is there, right? We can't create and we can't destroy.
Not be destroyed.
It has to be gain or loss. But it's a equilibrium here, right? So the heat energy lost equals to heat energy gained, where heat energy is losing metal, right? So which one is heat is getting? Water. And one or two times read and understand first that question. Metal, they immersed in water. 150 degrees Celsius of the metal. That means it is in the temperature, high temperature only. Such type of metal, they put it in the water.
Okay,
So
ma'am, then
what will
they decrease the
happen?
temperature.
Yes. So it will lose the
Decrease.
temperature metal. The water
Okay.
gains the temperature, right?
Yes, ma'am. Okay,
Ah,
okay. That is interesting.
yes.
Okay.
So calculate
Okay.
the specific heat capacity of the metal. We have to find out now specific heat capacity of the metal. So same
Okay.
formula, heat energy formula only, delta Q equals to mc delta T. Understanding? So delta T is change in temperature. So what metal temperature is different changing, and what water temperature also different.
So I
So
have to find two temperatures.
yes, two times, and we
Like,
have to equate
okay.
because how much here it lost, that much water gained. Do you understanding
Yes.
heat? So
Yeah.
heat,
Yeah,
how
yeah.
much metal lost, that much of heat water gained. So it's equal there. So ninth one, given mass of metal M1 equals to 50 grams and change in temperature delta Q1 equals to 150 minus 20. Initial is 150, final is 20. Changes. So 150 minus 20, 130. That is 130 Kelvin. Next, we want to find out specific heat capacity of the metal only. Oh, delta T instead of delta Q I have written. Delta T1. So delta Q equals to M1 C1 delta T1. 50. This is in the grams, we have to convert, right? No need. They given specific heat of water also in grams only. Don't change. Look at all the units. They given answer also in the grams only again. So don't change grams. So be careful here, units. If specific heat also in the grams and mass also in the grams, so no problem, no need to change. So 50 into C1 into 130. That is 0, 0, 15, 6500 C1. Next, same way, we are going to write water. 100 grams water. So, mass of water M2 equals to 100 grams. Next, change in temperature 11 degree and 20. That means here gained.
Oh,
20 minus 11, 9. 9 Kelvin. Next, heat capacity of water equals to 4.2 joule per gram per Kelvin. Delta Q equals to M2 C2 delta T2. 100 into 4.2 into 9. So we have to equate that now. So heat energy lost equals to heat energy gain. So heat energy lost is 6500 C1 equals to heat energy gained is 100 into 4.2 into 9. C1 equals to 100 into 4.2 into 9 by
ma'am, 37.
6500. Tell me,
Ma'am, I
ma.
multiply that 3780 by 6007.
Okay. How much will get it, you see? So 0 point only it will come. 5s are, because 37.8, so 37 is less than 65, 8 also we have to take, so decimal we have to take it 0. So 5 times 30, 32. Y means here 6, here 37. 5 times only it will go. Next, 6 times means it will cross. So 378, 325, 3, 5. Now already decimal we put 0. So 8 times it will go, we will check. 8 6 are 48, 52. Yes, 8 times it is go. Next again 1 0. So 1 time. 1 time. Enough. 3 decimals is enough. So joule per gram per Kelvin. They round up, I think, next decimal. Yeah, again we'll 0. Then it comes here again 5 times. They round up. 582 they put it. Okay, 10th sum you see. 45 grams of water at 50 degrees Celsius in beaker is cooled when 50 gram of copper at 18 degrees Celsius is added to it. The contents are stirred till a final constant temperature is reached. Calculate the final temperature. The specific heat capacity of copper is 0.39 joule per gram per Kelvin, and that of water is 4.2 joule per gram per Kelvin. State the assumption used. How to find out, pages? 45 grams of water at 50 degrees Celsius in a beaker.
Because
Yes. So it is cooled when 50 gram of copper at 18 degrees Celsius is added. Before,
yes,
the metal is immersed in the water. Now copper is immersed in the water to cool that. Okay.
yes,
So the contents are stirred till a final constant temperature is reached. Calculate the final final temperature. The specific heat capacity of the copper is 0.39 joule per gram per Kelvin, and that of water is 4.2 joule per gram per Kelvin. State the assumptions used. What and all they given, tell me, Tejas.
a mass of water
Temperature
and
of
then the
water,
temperature of
right?
water.
Next, mass of copper, temperature of the copper. But
The
final
copper.
temperature, we don't know. That's why we can't find out change in temperature. Understanding?
Okay, okay. Yes, ma'am.
So here, they're
Specific.
also asking final temperature only. Calculate, right?
Yes,
Next, specific heat capacity of both the given
capacity of
copper
water.
and water. Now find out, Tejas, same formula, heat energy lost, heat energy gain. Same thing only, you have to use now.
Same MC and delta T.
Ah,
Then it'll
so
be
first I will write
T
it
will be
given, water one I'll write. So water, what and all given, mass and temperature. copper, next water is same Tejas. Before how we use same. The water temperature is decreasing, copper temperature is increasing. So T minus T2. Now substitute 45 4.2 into 50 minus T. Here 50 0.39, here T minus 18.